Stanford University.
Well, welcome everyone to lecture number 7 of CS193P, fall of 2013-14. Today we're going to talk about input and output, okay? We're going to talk about views, which are rectangular areas on the screen that you can use both to draw custom stuff and to get gestures in from the user, touch gestures, multi-touch. I'm going to have a demo that's going to show you all that. We're going to build a custom view. It's going to have its own custom gestures and all that stuff. It's basically going to draw the cards that we used in Machismo were just really bad, like A clubs. They didn't look like cards, so we're going to actually have a custom view that looks like a card, right? It has the things in the corner and face cards, all that whole business. All right, so a view is of critical importance in iOS. It's right at the heart of all the drawing we do. You've used a ton of views already. Buttons are views, labels are views, okay? It's basically the building block that represents a rectangular area on screen. It defines a coordinate space, okay? A coordinate space you can draw in and a coordinate space that you can get touch events in and understand where they are. It's hierarchical. All right, so you can have views inside views inside views. All right, every view only has one super view, but a given view could have many subviews, and those subviews are just rectangles. They can overlap, whatever. They're not required to somehow be tiled or separate. They're completely free form subviews of a given view. And you can have any number of subviews you want for a given view. The order of the subviews does matter because they can be transparent. We'll talk about that. And one thing that's sometimes a little confusing is you have this rectangular area that's your view, but you can actually draw outside that area, perfectly legal. There is a little switch you can turn on in Xcode or obviously a property in UI view that says clip my subviews. In other words, don't let my subviews draw outside my view's bounds, right? So you can kind of keep things contained if you want. But that's not the default, and generally we don't. There is a UI window class, very unimportant in iOS. If we're on the Mac, UI window would matter. You have a lot of map windows on a desktop. But in iOS, it's all about views. There's only one UI window. It's the one that's containing all the views that are currently on screen. That's why in the last demo, I was able to say if self.view.window, then I knew I was on screen, right? Because that's the only window there is. And so if I am in it, then I'm on screen. So UI window, very unimportant. You don't ever even have to look at the documentation for UI window. UI views are what it's all about. So this hierarchy of views inside views, is most often built in Xcode, just by dragging views in. Now, we haven't done a lot of dragging views inside other views, but it's perfectly legal to do that. And you'll see in Xcode sometimes when you drag, it tries to drop it in another view. You might not even want it to, but it tries to. So a lot of it we build graphically. However, we can also build it in code. And we build it in code, build and tear down this view hierarchy in code with these two methods, add subview. Exactly what you would think. It just takes a view and adds it as a subview of some other view. You send that to the view that you want to be the parent view, right? That's the view to which you are adding the subview. On the opposite side, to get a view out of the view hierarchy, you send remove from superview to the view you want to remove, not to its parent. So you don't say remove from superview colon view. You just say to a view that you want out of there, remove yourself from superview. Okay, so it's a little different adding and removing who you ask to do it. Your MVCs, of course, have a view, and that top level view that contains all the views in the view hierarchy for your MVC is the property view in View Controller. So if you look in UI View Controller, there's a property called view. It's a UI view, and if you go in Xcode and right-click on your controller or right-click on the background of your MVC's view, you'll see an outlet, basically. It really is an outlet, this view property, and it points to that top-level view. So that's a good place to start if you want to start adding views in code to your view hierarchy. And of course, when you drag them out in Xcode, that's what you're doing. You're dropping them in, unless you're dropping it on top of another view, you're dropping into that background view, self.view. Okay, self.view, we use that phrase, self.view. Let's put it in self.view. Self.view is that top level UI view. in UI view controller. It's just a plain old UI view. It's not a subclass version. You never subclass that view. It's just kind of a big container view. And that's another thing to know about views, that you don't always subclass them to draw or do touch events. Sometimes they're just boundaries, right? It's just a view, you want to define a coordinate space and you want to put some other views inside of it. Perfectly fine. We do that. So initializing a UI view, a little more common to want to override the designated initializer of a UI view in a subclass. Remember in UI view controller, we kind of said, we almost never do that because UI view controllers are almost always coming out of storyboards, so the designated initializer never gets called anyway, so we just do awake from nib, okay? And we never do that with nib name bundle thing. That's not true in UI view. In UI view, you do more often both need to do something in your initializer and just want to have your initializer around and code in there. So, but when you do it, you want to also do awake from nib. Okay? That's because UI views are equally created, well not equally, but at least they're commonly created both by dragging them into a storyboard, so that would be the awake from nib initialization, and by sending alloc init to them. In other words, in your code, creating a view. So for example, in your homework, you're going to have to do set cards and playing cards for real, not as buttons, but actually drawing them. And you will almost certainly be alloc initting those views because there's not a fixed number of them, so you can't really drag them out in Xcode because they have to come and go. So you'll be doing that. So we do the same kind of thing we did with UI view controller, right, where we have some kind of setup method. You can call that setup thing whatever you want. And then you call it from awake from nib. And then you also call it from UI view's designated initializer, which is called init with frame. And that frame specifies where this view is in its superview's coordinate system. It's the positioning of this view. Okay? So that's what the code would look like, just like that. And you put your initialization code and setup. And we'll do that in the demo, just so you see that. Now, before I can talk more about UI view and drawing there and getting events, we got to define a few types here. One is CG float. This is a floating point number. All floating point numbers that have to do with drawing on the screen or getting touch events or whatever are CG floats. This might be a double, it might be just a regular floating point number, it might be 32 bits, it might be 64 bits, you don't know and you don't care, but you always have to use CG float. Not only using CG float to specify positions on screen and all the things, but if you're going to be multiplying or adding numbers to things that are on screen to recalculate new things, you want to do all of that in the CG float domain. So you're going to have a lot of properties and local variables that are CG floats when you're doing screen stuff, okay? Then there's a C struct called CG point. That has just got two elements in it, X and Y. That's an X and Y position, okay, in the drawing world. And there's CG size, which is just a struct with width and height, which are both CG floats also, and that's just specifying a width and a height. And then there's CG rect, which is a C struct with those other two CG structs in them, CG point and CG size, and that specifies an origin and a width and height for a rectangle. Okay, so you got to know these four. I'm going to refer these left, right, and center. Whenever we're drawing on screen, this is what we're talking about. Okay? The origin of a view's coordinate system for drawing or for handling events is upper left, not lower left, not like Cartesian coordinates. Okay, this is drawing from the upper left. So positive y values are down the screen. Okay, so you can see I put that point up there, 400, 35. That's x and y. X is 400, way over to the right, and 35 is y and positive, so it's down from that origin in the upper left. Okay. The units in all this drawing are points, not pixels. Okay. Probably you already understand why this is, because some devices have lots of pixels, right? I mean, very high density pixels like these Retina displays. Other ones, like some of the iPads, older iPhones, they don't have as many, they're not as dense of pixels. Well, if we didn't use points, if we used pixels, then things we drew would be really small if the pixels were small and really big if the pixels were big. So we abstract that away by using points. Okay. How many pixels per point are on the display that your view is in? You can find out by using this UI view property content scale factor. So it would return 2, for example, on a Retina display, because there are 2 pixels per point on a Retina display, 1 on a non-Retina iPad, for example. Probably not going to need to use that property in this class this quarter. In previous quarters, we've played around with it, but not this quarter. But more importantly, there are these properties that talk about the position and extent of your drawing system, okay? And it's really important to understand the difference between these properties. First, you have this CG rect property bounds. That is the origin and width and height of the drawing area in your own coordinate system. Your own coordinate system, the coordinate system you are drawing in and handling touch events in, okay? CG rect frame at the bottom there, that is a rectangle that completely contains you in your superviews coordinate system. So you can see how that positions you, right? Because that's in your superviews coordinate system. That's where you are. Okay? Center is just the center of where you are in your superviews coordinate system. There's no property to get your center in your own coordinate system. You just take your balanced out width divided by 2 and height divided by 2, and boom, you're in the middle. Okay? Now, you might think frame and bounds are going to be exactly the same, except for that the frame is going to be in the superviews coordinate system, so the origin might be different, but that's not true, okay? And the reason for that is that views can be rotated, okay? And if a view is rotated, you can see that the rectangle to contain it might be much bigger, right? Because it's a diamond shape that it has to contain, okay? So there's some details on here on this slide. You can look at them at leisure, but the bottom line is understand that frame is a rectangle containing you in your superviews coordinate system. Bounds is the rectangle you use to draw when you're drawing in your own code in your view. It's your coordinate system. Yeah.
When would the origin of bounds not be 0, 0?
When would the origin of bounds not be 0, 0? That's an excellent question. The origin of the bounds, since it's your own coordinate system, is up to your own interpretation. So, for example, scroll view uses the origin to say, where am I looking in the thing I'm scrolling on? That's just the way it defines origin. You can define what you want origin to mean, okay? Because you're going to be asked to draw, and you know your own coordinate systems, you're going to draw whatever you're asked to draw. So it's kind of up to you. 99% of the time, your origin is 0, 0, because it doesn't mean anything for you. It's just the width and height that matter. But that's a very good question. Okay? So again, you can look at this slide to get more detail, but frame and bounds, just want to make sure you understand that. Most often you create views by dragging them out of the palette in Xcode, and that's like when you're dragging out labels and buttons and scroll views and text views. Those are all views, and so you just create them by dragging them out. And you can even drag out your own custom views, but the way you do that is you drag out a generic view and then go to the identity inspector and change its class. Exactly like how when we drag out a view controller, we have to go change its class to be one of our custom classes, right? Because Xcode obviously doesn't know our custom classes, or at least it doesn't know in the kind of runtime way that's happening in a storyboard, so we have to set the thing. So it works exactly the same as setting view controllers. Creating a view in code, in other words, not dragging it in to a storyboard, you just use alloc init with frame or just alloc init. If you do alloc init, that's the same as alloc init with frame CG rect 0, which is a rectangle with origin 0, width and height of 0. Okay? So you can do either one. If you do alloc init, presumably you better set the frame to something so that it knows where to be when it's put into its super view. So here's an example of creating a UI label in code. You see I said UI label init with frame. I gave it a rectangle. That's in the superviews coordinate system. And then I add subview that label to self.view, which is that top level view in my view controller. And so it ended up at 2020, 20x and 20y, and it's 50y and 30 high in my MVC's view, right? Now, you wouldn't probably ever create a label like this because you drag them out, but you might create your own custom view like this, right? Okay, so when do I want to create my own custom views? Obviously when I want to draw something custom, not something that a button or a label can draw for me, or when I want to handle special touch events, swipes or pinches or something like that. So the drawing side of this, which we'll talk about first, is really easy. There's one method in UI view called drawRect, and all you have to do is implement that method to draw what you want. Okay, one method, that's it. You implement this method to draw what you want. Now it has that argument there, that's a performance optimization. That's basically a rectangle that says, well, please draw yourself, but really I only need the stuff that's in this rectangle in your coordinate system. But if you want to ignore this rectangle and draw all of yourself, that's fine by me. Okay, so it's purely a performance thing. Some views, it'll make sense to look at that rectangle and be really efficient. Like we had an assignment a couple years ago in this class where you're drawing a graph. Well, if you're drawing a graph and you're having to calculate every point, it's kind of nice to only have to calculate the points in some part of the graph instead of drawing the whole thing every time. But if you're drawing a playing card, it's so lightweight to draw it, you can just draw all the parts of it. You don't have to use the rectangle.
If you draw outside of the rectangle, does that stuff show up?
The question is, if you draw outside the rectangle, does that show up? Remember that everything you draw shows up unless you have one of these clipping things I talked about on where you're like your super view is clipping you, or you have a clip rect as part of what you draw. So the answer is that rectangle has nothing to do with clipping. Okay? No matter what that rectangle is, clipping or not, is unaffected. Okay? It's purely performance. I'm giving you a hint of what needs to be redrawn. That's all it is. So really important. Never call draw rect. If you call draw rect in a homework assignment in this class, you are going to get dinged because I'm putting it in red, never red, and I'm telling you, don't ever call draw rect. Draw rect is for the system to call. Okay? If you want your view redrawn, you call the method set needs display. And that tells the system this view needs to be redrawn. And then the system will call draw rect at an appropriate time. Okay? The system knows when it's an appropriate time to call draw rect, update off-screen buffers, whatever heck it has to do. It's in control of that. Don't ever call draw rect. It just will not work to call draw rect. Okay? Set needs display. And you can do set needs display in rect. That's giving the little optimization rect. Okay? But set needs display is how you do that. Okay? All right, so how do I implement this draw rect thing? Okay, I got this draw rect method. I want to draw something. Well, the answer is you use this library, the Quartz library. It's called Core Graphics. Core Graphics. It has a ton of C functions that all start with CG, Core Graphics. They almost all take a context as the first argument. We'll talk about that. Or you can use this nice class called the UI Bezier path. And UI Bezier path lets you build all these complicated shapes into a big path, and then you can stroke it or fill it on screen. Okay, so let's look into these. To understand these, we need to understand a little bit about how Core Graphics thinks, and it thinks in the following four-step process. You got to have a context to draw in. You got to create paths, triangles, squares, whatever, rounded rects, whatever it might be. Then you set the colors and the fonts you want to use and line widths and all that stuff, and then you stroke or fill the paths that you created. This is the fundamental way Core Graphics goes. Okay, so let's talk about all those things. UI Bezier path, by the way, encapsulates doing all of that. Okay, it takes care of the context for you so that you don't even have to think about that. You create paths by sending messages to a UI Bezier path instance. It lets you set colors and line widths and all that, and then it has methods to stroke and fill. So it encapsulates all that mechanism. So let's talk about the context. Mostly you don't have to worry about context because you're going to use UI Bezier path. I'll show you a way if you're using the CG functions to get the context to draw on screen. But a context means where am I drawing in terms of am I drawing on screen right now? Am I drawing off screen in some bitmap? Am I creating a PDF file out of what I'm drawing? Am I drawing to a printer? The iOS has great printing support, and so you could be drawing to print a page on an AirPrint printer or something like that. So that's the context part of it. For normal drawing, UIKit sets this context up for you before it calls drawRect. And then once you're in drawRect, context is ready to go. UI Bezier path knows what it is. And if you want to call the CG functions, you call this method UI graphics get current context. If you call this inside your drawRect, you'll get a little cookie that you can hand off as the first argument to all these CG Core Graphics functions. Okay? And you're not going to need those CG functions very much, only when UI Bezier path won't do what you want, which is pretty rare. Okay, so this is the magic thing. That context ref is just, it's a void star. You don't know what it is. It's opaque. This thing is new every time your drawRect is called, so never keep that thing around. It's only good from the start of your drawRect to the end. Don't keep it in a property or anything that's going to live. Okay, call the UI graphics get current context each time at the start of drawRect. Okay, so how do we define a path? So let's say we want to do a triangle with UI Bezier path. We alloc init a UI Bezier path like this. We move to wherever our starting point is. So I'm going to move to the top there, 75 across and 10 down. Then I'm going to add a line to that point, going down to over to 160 down to 150. I'll add another line to come back to 10, 150. And then I'm going to close this path by calling close path. That goes back to where we draws a line back to where I started. So I have a nice triangle there. Now I'm kind of misleading you because as I'm making all those calls in UI Bezier path, nothing is actually happening. Okay, the screen is blank. Okay, because all I'm doing here is building that path up in that UI Bezier path. I haven't actually drawn it yet. When I want to actually draw it, I have to set my fill color and stroke color, and you can do that by sending set fill and set stroke to a UI color. Just get a UI color like you did for attributed string or whatever, UI color, same thing. Call set fill or set stroke. You can even just say set and it'll set the fill and the stroke to be whatever color you send it to. And once you have your color for fill and stroke set, you send a message to the path saying fill and or a message to the path saying stroke. And now it will actually draw. So those last two calls there, fill and stroke, those are the things that cause drawing to happen. Okay? Everything else is just like setup. Make sense? Okay, now this might all seem like, whoa, triangle, great, I can draw a triangle, sounds easy, but there's actually a lot that UI Bezier path can do that's really much more sophisticated than that. You can set your line widths and things like that to make your drawing, you know, you can set patterns and all kinds of stuff like that to make it more interesting. And also UI Bezier path has a lot of cool functions like Bezier path with rounded rect corner radius, okay? And that will give you a path which is a rounded rectangle inside of certain bounds, okay? And it has a bunch of other ones similar to that so that you can build more complicated things than line 2, line 2, line 2, okay? I just show you that because it's simple, right? So that's how you would, for example, create an oval. You can also use UI Bezier path to clip your drawing. This is super important. You will need this for your homework, I think. I suppose there's a way to do the homework without this, but I can't think of a way. Well, I can, but it would be extremely tedious. Rounded rect, for example, could be used to clip your drawing. So if you wanted to draw some kind of pattern, but you wanted it to be inside a rounded rect, you just get a rounded rect, just like earlier in the slide there, and say add clip. And at that point, from that point on, all your drawing will be clipped to be inside that Bezier path. Okay? And there's ways to add more clipping, to turn off your clipping, that kind of thing. So clipping, important piece of UI Bezier path as well. Okay, let's talk about drawing with transparency in UI view. Okay, UI views by default are opaque. They have a background color. By default, it's white. And so if you put a view on screen and just run, it'll come out as a white rectangle. Okay? So that's not always what you want. So for example, in a playing card, I want it to have rounded rect. And I want those corners to show through. Maybe there's a card behind or something on the playing table that the card is on or something. So I don't want it to be opaque. So you're going to see in our demo, we're going to have to turn this opaqueness off. The way you turn the opaqueness off is you have to set this property opaque in UI view to no. In other words, you have to tell the system this view is not opaque. Even if you set the background color to nil, okay, which means I don't want a background color, it still won't be transparent because of this. This opaque isn't a performance optimization, but it's a hard optimization, meaning it just won't work if you don't set it to the right thing. So if you want your view to be transparent, you have to set opaque to no. You're also going to want to set your background color to nil so that it's not filling with a background color. It is also possible to make your entire view transparent with alpha. Okay? So UI view has a property called alpha. If you set it to 50%, then everything in your view will be 50% see-through. Right? 50% transparent, or 20%, or whatever percent you want. That's the entire view, no matter what's going on inside. And of course, you have transparent colors that you could draw with, fill with, stroke with, whatever, to draw transparently that way as well. So there's a lot of ways to draw transparently in your view. What happens if you draw transparently and views overlap? Well, they show through to each other. Okay? And I told you that the order in which you add the subviews matters. Okay, every view has a property, an NS array called subviews. It's the list of views. And the order matters. The lower ones in the array, okay, the ones that like at 0 are in the back, and the ones down at the end are in the front. All right, so the subviews array is from back to front. Okay, and things can overlap and whatever be on top of each other, and they will show through. If you had an opaque one in the middle, it would all of a sudden block all the ones in the back. You see what I mean? So it's as simple as that. Now, having transparent views is not cheap. We talk about performance optimization, and one of the biggest mistakes I think computer science students make is premature optimization. You're in there optimizing stuff that just doesn't matter. This matters. If you have a lot of transparency, it's going to be a performance hit because you're talking about having to composite those views on top of each other with alpha, way more expensive than just blasting the bits in there. Okay, anyone who's taken graphics knows what I'm talking about. So this is something to be a little careful with. If you're going to set that opaque to no, understand there's a performance cost there. Yeah, that's what I'm saying. You can also hide a view entirely. Okay, so it's just like, think of it as alpha of 0, like you can't see anything, but it also won't get any gestures. It's almost like removing it from the view hierarchy, but you're leaving it so it has its space in the subviews list. It gets to keep that, but otherwise it doesn't appear. It doesn't draw, doesn't get events. It's like it's not even there. Why do you want that? Well, because sometimes you just want to temporarily remove a view from the hierarchy and then put it right back in. So you said, or put it back in some short time later. So you say hidden equals yes, it's gone. You say hidden equals no, oh, it reappears, okay? So that's better than setting the transparency, although I think mostly the UI kit probably optimizes alpha equals 0 to be the same as hidden, is my guess, okay? Probably won't have to do that in your homework, is my guess. But you might, depends on what kind of sophisticated UIs you build. I'm not going to go through this slide, but you can imagine that if you're setting up fill colors and clipping and all that stuff in a subroutine, when you come back from the subroutine, all those things might still be set, and that would be bad. Okay? So you want to be able to push and pop your state, basically save the current graphics context and then restore it, and that's what these functions do. CG context save gstate and CG context restore gstate will save everything, all the fill colors and clipping regions. You go do a bunch of stuff, you know, clip and fill and everything, and then you restore and you're back to where you were. So that if you have your draw rect and it calls this draw green circle thing, it won't come back to your draw rec, and now everything's drawing in green. Okay? So that's a push and pop, basically, of the state. All right, drawing text. Okay, it's all great drawing triangles and filling them with colors. What if you want to draw text inside your view? Well, of course, we use UI label to draw the vast majority of text on the screen in UI kit, but you can use NS attributed string to draw any text you want. And it could not be simpler. You create the attributed string with all the attributes you want, no restrictions, exactly like you learned to do in this last homework assignment. And then you just send a message to that attributed string, draw at point, this point. And that will be the upper left corner of a rectangle that includes all of that attributed text. Okay? It could not be any simpler. You can also find out how big that text is going to take, how much space that thing is going to take by sending size to the attributed string, and it'll tell you how big it is. Now, you might be a little disturbed by this and like, whoa, attributed string is not really a UI kit thing. All the properties inside usually are, but it itself is not. And that's true. UI kit actually adds these methods, draw at point and size, and there's a few other ones. It adds them, even though it's in a completely different framework, using a mechanism in Objective-C where you can add methods to classes without subclassing them. Okay? It's called categories. It's talk about Wild West. That's why I don't show you until about halfway through, because it can be abused, this mechanism. But that's how this is working, for those of you who are wondering. Drawing images is almost the same, but instead of an NS attributed string, you get a UI image. So you know how to get one out of the image asset library with image name. There are other ways you can create them from files. You can even draw into an off-screen bitmap to create a UI image. Once you have a UI image in your hand, you just send it draw at point, which will draw that image with its upper left-hand corner at the point you specify, or draw in rect, which will scale the image to fit in the rectangle you specify. Okay, this is a scaling one. Or draw as pattern in rect, which will like tile the image, you know, repeat the image to fill the rectangle that you specify. Okay, and you can get other representations, PNG representations of things you've drawn and all these things. So I just want to let you know that's in there. You don't need it for your homework, but anyway. So drawing text and images, really easy. It's just attributed string and UI image, draw at point, draw in rect. Okay. What about when your bounds change? Okay, you noticed when you did the navigation controller or the tab bar, you know, your bounds of your view got shrunk down to fit the thing at the bottom or fit the thing at the top. And also, if you rotate your device, obviously bounds are going to change. What happens when your bounds change? Well, by default, the bits of your view that were last drawn will get stretched, okay? Which really is almost never what you want, okay? I mean, most content wants to be drawn to get high resolution and have it look nice. So the default is that because it's way high performance than asking you to draw again. But there's a property in UI view you really want to know called content mode, and it says what happens when your bounds change. And the one down at the bottom there, UI view content mode redraw, is doing what you imagine, which is it asks you to redraw your whole view with DrawRect whenever your bounds change. Okay? So in our demo, we're going to set it to redraw because if our card's bound ever change, we want to redraw. So we get a nice sharp face card image or the right size little pips on there and text and all that. So you might want to do that as well. Okay, UI view content mode scale to fill is the default. That's the bit stretcher. Okay, so that's the drawing side of things. Now let's talk about the input side, okay, the recognizing gestures. It is possible to get the raw data about fingers touching the screen, how many are touching, where the fingers are, when they move, and it used to be that you actually had to look at all that data to figure out what the heck the user was doing, swiping or pinching. It was a nightmare. I mean, I can't believe people actually did it. It was quite esoteric code. But the last few iOS releases have had the right way to do it, which is gesture recognizers. Okay? So the way we're going to understand what the user is doing is the system is going to recognize certain gestures for us and tell us when those gestures are happening. Okay? The obvious way you would want to do this. The class that is the base for all these recognizing of these gestures is called UI Gesture Recognizer. It's an abstract class. Okay? You never instantiate it. But it has a lot of concrete subclasses like pinch gesture, tap gesture, all that. And those are the things that does the actual recognition of a gesture and communicating with you when it does. There's two parts to using a gesture recognizer. You have to create a gesture recognizer and add it to a view. You can only add a recognizer to a view because views are the ones that have a coordinate system to know where the touches were that caused the gesture to happen. And then number two is you got to provide a handler, a method to call when the gesture happens or is happening. If it's like a pinch, it's, that gesture handler is going to get called a lot as the pinch goes out and in, or if it's a pan, okay? But if it's a swipe or a tap, you're just going to get called once. Make sense? So those are the two things you need to do. Usually number one is done by a controller, although sometimes views do it to themselves where they add a gesture recognizer to themselves. And number two is often provided by the view. In other words, the handler, the thing to do when the gesture is happening or happened, a lot of times the view implements that method. So even though the controller might add the gesture recognizer to the view, when it adds it, it tells the system, oh, and when you recognize this gesture, let the view handle it. But the controller can handle it itself. So we'll do both in the demo. We'll have the controller handle it, we'll have the view handle it, the whole deal. So let's take a look at the code, what a code would look like to add a gesture recognizer to a view, a gesture recognizer to a view in a controller. So this code that I'm showing right here is in a controller. It's the setter of an outlet for a view called Panable View. Okay, that's the name of the outlet, Panable View. So this was just control dragged, wired up, and now as an outlet, and now we're in the setter. And in the setter, what we're going to do is when that view is set in our controller, we're going to add a gesture recognizer to that view so that that view starts recognizing the pan gesture. Pan is put your finger down and move around. Okay, that's called panning. So it's very simple. You can see that we create a concrete subclass of gesture recognizer called UI Pan Gesture Recognizer. You see that there in the yellow bubble. And when we create it, you can see its designated initializer. All the concrete classes designated initializer take two arguments. One is the target. That's who's going to handle this gesture when it happens. And the second thing is the method to call in that object. So here, pan is going to be sent to the view itself, the same view that we're going to add this gesture recognizer to. And then we just do the step of adding the gesture recognizer to a view. The method add gesture recognizer is only implemented by UI view. So a controller can't recognize a gesture. It has no coordinate system to do that in anyway. So some view has to be handling this gesture. And yes, you can have self.view recognize gestures, right? The whole view, that's perfectly fine. And yes, the target in action could be the controller, a method in the controller. It doesn't have to be a view. Okay? That can be any object. So how do we implement that target, that pan colon, right? So I'm panning or I'm pinching and I'm getting sent pan colon when I'm panning. What do I do inside that method? And the answer is that each concrete subclass of UI gesture recognizer will provide some methods to help you. Okay? So for example, the pan gesture recognizer provides these three methods. Translation in view, that's how far the touch moved since basically it was last reset. Okay? And it starts off reset when the touch goes down. So as you move, unless you reset it, which you can do in your recognizer, we'll show you that, it's going to tell you the cumulative translation distance from where you started. Okay? So that's translation in view. Velocity in view is how fast it's moving. Is your finger moving quickly? Like it's like almost like a swipe or something? Or is it moving really slow? Is the user trying to really do some detailed work? So this is telling you the velocity. And then set translation in view allows you to reset the translation. Okay? Because I told you translation in view is since the last reset. Set translation will let you reset it to some point. And then the next pan colon you get, the next finger movement, the translation will be from the place you just reset it to the last time. Okay? So those are given to you by pan gesture recognizer, and you also inherit, pan gesture also inherits a very important property from UI gesture recognizer, the abstract superclass, called state. Now, state can be a lot of different things. Here's some of the more interesting ones. UI gesture recognizer state began means this is a continuous motion kind of thing, like a pan or a pinch, and it just started. The finger just went down. Okay? Then UI gesture recognizer state changed means it's one of those continuous things, and it changed. The finger's moved. Okay? Changed means it moved. And then there's UI gesture recognizer state ended. Finger went up. Okay? Exactly what you would think. But there's other states, like UI gesture recognizer state, what's it called? Recognized. Okay? That one you get for discrete gestures like taps or swipes. You don't get all this began, moved, or began, changed, ended. You just get recognized. I recognize the swipe. I recognize the tap. You see? See the different state there? So you recognize you'll never get on the continuous ones. Well, you might get it, but you wouldn't pay much attention to it. But on the discrete ones, that's when you look at it, and vice versa with the began, changed, and ended. You can also get canceled and failed, things like that. These happen when things like you're in the middle of a gesture and a phone call comes in. Okay? Boom, that gesture just got blown out of the water. So really good code will pay attention to failed and canceled and make sure things aren't in a wacky state if the thing gets aborted right in the middle. So I'm not going to show that in the demo because time is going to be of the essence here, but you can look at the documentation how to handle those. All right, so what would pan look like, given that we have those methods that the concrete thing provides? So I'm probably not going to do anything when the finger first goes down, because nothing has really changed yet. But as soon as it starts changing, or when the finger goes back up, I'm then going to update something inside my view based on where this new position is. And I'm going to get that new position by asking the recognizer, the pan gesture recognizer, what's the translation in the view self. Okay? Well, the reason we specify the view when we say the translation is because we need a coordinate system. Okay? We've got to know what coordinate system we're talking about this translation being. Right? So self in this case, because pan colon is in a view. Like I might set my origin or some property. This is just an example line of code. If I had a graph or something like that, maybe I'm moving the graph around, just constantly resetting the origin. And here, since I'm moving the origin from where it exists at the time this is called by some little translation, I want to reset that translation every time so that I'm always getting little incremental translation movements, and I'm moving my origin around incrementally. Otherwise, I'd have to keep track of where did my origin start, and then every time this was called, I'd have to find the difference and then move it that much. This way, I don't have to worry about it. I just keep resetting the thing back to 0, and so I keep getting these tiny changes, and I just keep applying them to my view. And this is a very common pattern to do this for these continuous ones. We're constantly resetting. And we'll do that in our demo. We're going to do pinch, but we'll do the same resetting. Okay, so let's look at some of the other concrete recognizers. Pinch. Okay, pinch doesn't have translation, it has scale. So when the pinch first starts, the scale is 1, 1.0. And as I go out, 1.1, 1.2, 1.5, 2.0, 1.5, 1.2, 1.0, 0.9, 0.8, 0.7, 0.6. Okay, that makes sense? So that's what's happening there. And then the velocity is how fast in scale factor change per second that's happening. So are you pinching really fast in, pinching fast out, et cetera. So that's giving you, again, some indication what's the user, if they're pinching out really quickly, repeatedly, maybe they're trying to really zoom out fast. You could zoom out faster than usual or something. Rotation gesture recognizer, also a 2-finger thing, like a pinch, except for you turn your fingers. And it's going to tell you the rotation in radians. Everyone know what radians are, right? 0 to 2 pi around a circle in radians. Look it up if you don't know it. And that's also telling you velocity in radians per second, how fast the person's rotating. Swipe gesture is one of these discrete gestures. You just set up this swipe gesture, you allocate it with the target in the action, and then you set these properties direction or number of touches required. Number of touches means this is a swipe with 2 fingers or 1 finger. That's what number of touches means. 2 finger, 1 finger, 3 fingers, 5 fingers, whatever you want. And the direction is left to right, right to left, top to bottom, or bottom to top. Okay? So you create it, and then if a swipe happens that meets all that, you'll get your handler called once with recognized as the state. Does that make sense? So a swipe is something you don't track. It just tells you, oh, I saw a swipe. And yes, it's smart about if you have a pan gesture recognizer and a swipe gesture recognizer, if you swipe smoothly enough, it'll see it as a swipe. But if you go slower or you don't go, across, you're going in a diagonal or something like that, it'll say, oh, no, that's a pan. Okay, so it knows how to kind of tell the difference between gestures, okay, as much as possible. It's pretty cool. Tap gesture, just like swipe gesture, right? It's discrete. You set it up, how many taps, double tap, single tap, how many fingers, et cetera, and it'll send you recognized when it sees it.
Can you do swipe gesture recognizers 4 corners, or no? Or is it only those 4 directions?
The question is, can you do swipe gestures like you mean like swiping up into a corner as opposed to...
Right or something like that.
I don't think so. I think it's just left, right, up, and down. Okay. I could be wrong about that. I haven't looked in the documentation for a while, but I think it's only those 4. All right, so let's do the demo. Okay, it's just going to be, I'm going to go faster. This is a lot to show you here, okay, but I'm only going to show you all the things we just talked about today, but I'm going to try and show all of it to you in a comprehensive demo. Let me talk about what's coming up so that we can just finish the demo and be done. Again, we're hoping on Friday to get this University Developer Program thing going, but it looks like that's still not working. Watch Piazza tomorrow for whether Friday is canceled. At this point, it's not looking good. That would be a Stanford-only thing anyway. The homework, as I said, is due a week from Monday, so more than 7 days from now, a week from Monday. I really strongly recommend you get started on the part that is a custom view and gesture recognizer immediately. Do not wait until next Tuesday or Wednesday, because then you're going to find that this is a lot of work for this assignment to try and jam into 1 week. That's why I've given you, whatever, however many days it is. Do this part. I would try and do this part before next Monday if you can, but certainly do this part as soon as possible. Then the rest of the part, which is animation and auto layout, which I'll be talking about on Monday and maybe next Wednesday, you can leave that. You can do that after you do this part. They're not so intertwined that it's like, oh, you got to do them all at the same time. It's something you can do after. Okay? Okie dokie. So we are going to create a new project in Xcode here. And I'm going to call it, I'm going fast through a lot of these starting up things because you know how to do this already. So I'm going to call this one SuperCard. One thing interesting here, I'm not going to specify a class prefix just so you see what that looks like, because we've always specified that like card game or something like that. So I'm just going to not specify that, and we'll see. I'm going to create it in my home directory developer as I usually do. Here you can go and see right here where it says viewcontroller.h and viewcontroller.m. That's the name of my view controller classes, which is really, those are bad names. And that's why we usually want to put something in that class prefix like card game view controller. Okay? I'm going to move these down out of the way. Otherwise, here's my view, right? My storyboard view. And I could bring up the controller for it right here. You can see I've got a view did load, which I'll go ahead and leave. Memory warning, don't need that. Okay, and all I'm going to do in this view, it's a little smaller, is put a single view, custom view, which is going to be a playing card, but a real playing card, drawn playing card. Okay, so let's start by doing what we always love to do, which is setting our background here to moss. I love moss. There it is. Okay, there's our moss. We like that. I'm doing that mostly so you can see what's going on better. And then I'm going to grab this custom view out of here. So let's go down here. UI view is pretty far down, past halfway. There it is. See right here, view represents a rectangular region which draws and receives events. And you just drag it out and put it out here. I don't want it to be this big, so I'm going to make it smaller. It really doesn't matter exactly what size I make this, because I'm going to make my class, my drawing class, so that it'll draw properly in pretty much any size. Now it's going to look pretty bad if it's not, you know, mostly tall than wide, because playing cards don't look very good if they're wide and short. Okay, my view will work. It won't, people won't recognize it very much as a card, but it certainly would be fine. And in your assignment, the custom view you're going to create, you also want to make it that way so that it works in any size bounds. And in that card, since it's going to be a set card for you, set cards actually could make sense being sideways. You would want the three symbols, you know, going sideways instead of up and down. So a good solution would make really any aspect ratio look nice for a set card. But playing cards mostly only going to look good kind of set up. So what we do here then is we go to this identity inspector, and here we want to set our class of this view to be some custom class, right? Right now it's just a generic UI view. And so let's go create that class. So I'm just going to do File, New File, just like we always do to create a class, Objective-C. This one's going to be a subclass of UI view, okay, instead of UI view controller or anything else. I'm going to call it Playing Card View. Okay, this is going to be a generic playing card displaying view. Completely generic, not tied to the Machismo model, not tied to anything else. It's just like standalone. And remember that when we create views, things that go in the view camp, they want to be as generic as possible and reusable as possible, so that I could use this playing card view in my poker game app and also in Machismo. Okay? That's why we really want to try and enforce that kind of generic nature of it. So here's playing card views implementation. You can see that I've got init with frame right here. That's its designated initializer. And you can see I've got the all-important draw rect commented out. If you comment this out and you don't put anything in there, that's going to be a performance hit, because it's going to think this view needs to be redrawn all the time when in fact it doesn't. So that's why it starts out commented out. But we are going to draw in here, so we will be commenting it out. I'm going to move this. We're going to do something in there, but I'm going to move it down out of the way because we're going to do that at the appropriate time. Okay, so anytime we create a new class, really important to think about its public API. So let's do that. Let's look at its public API. It's a view, right? What does it need to do? Well, this playing card needs to display, playing card view needs to display a playing card, so we better have some way of specifying which card we want. Now some of you might say, oh great, let's use card star, or playing card star would be great, because playing card star's got everything we need. But again, I don't want to tie this generic reusable view to that model. So instead, I'm going to have NSU integer rank, and I'm going to have NS string suit. And I'm also going to have something that's not even in that other model, which is non-atomic bool face up. Okay, so I'm going to have, so my card is either face up or face down. This is a playing card view. It's got to be able to display the card in either up or down. So that's my API. That's all I really need. And so we just got to implement that API in our implementation. One thing I'm going to do right off the bat is this. Okay, now I typed this really fast. Whew, that was it. All I'm doing here is all the setters for all my public API, I am calling setNeedsDisplay. Okay? Because if someone changes the suit or the rank, and yes, I could say if underbar suit does not equal suit and save myself a setNeedsDisplay, but okay, demo time here. So I'm doing setNeedsDisplay just to make sure if anyone changes the rank or the suit or the face upness of my thing, I tell the system I need to be redrawn. Do you all understand this, why I do that? Okay, excellent. So let's dive into DrawRect here. I'm going to uncomment it out. okay, and start drawing here. Now, if I'm going to do all my stuff with UI Bezier path. Well, actually, no, I'll do a context here just to show you the context. We'll do it a little later. But we're going to start off doing UI Bezier path. And let's start with the outside of my card, which I want to be a rounded rect. Right? I want my cards to be a rounded rect. So I'm just going to create a Bezier path here, UI Bezier path. I'm going to call it, let me make some more space so we can see lots of code here. Rounded rect, I'll call it. And I do that with UI Bezier. Actually, there's a class method that does that. Rounded Bezier path for rounded rect down here, this one. And I'm going to have that rounded rect be as big as possible. So I specify self.bounds as the rectangle to draw this rounded rect in. Okay, self.bounds is my coordinate system. Its width and height is the amount of space I have on screen to draw in. Okay, corner radius. I'm going to throw in some magic code here for that. This is an important thing. This corner radius is how many points is in the radius as it goes around the corner of the rounded rect. And really that number depends on how big my card is. If I have a big card, I want a big radius. If I have a really small card, I want a really small radius. So I've created this corner scale factor, which I've just standardized to some height, and I can play with these numbers to see what works for all sizes. And then I'm going to pick a radius that at this height is 12, and that works pretty nicely, right? And then I'm going to scale it. Okay, so I'm going to call this method right here corner radius. And you'll see I'm going to use that scale factor in other places too to try and scale it up. And this is part of what I'm talking about. You need this thing to draw in any size bounds that makes sense. So you're going to have a little bit of stuff that is dependent on, the size and height of this thing to pick the right size rounded rects and things like that. So the first thing I'm going to do with this rounded rect actually is I'm going to clip to it. Because add clip. I'm going to, I don't want to ever draw outside that rounded rect. Okay, that's the interior of my card. So I'm just going to clip to that. It also lets me do something like this. UI color, white color, set my fill color. And then I can just, sorry, I do that a lot. Then I'm just going to use this C function because I just want to show this to you. UI rect fill, and you specify a rectangle, self.bounds. Okay, this just fills this rectangle. So it's kind of like shorthand for creating that path, filling it and all that stuff. It just fills it. It's a nice little UI kit thing. And this is going to make a big rectangle, but this clip is going to keep the white of this on the inside of that rounded rect. So it's not going to draw the white in the corners up there. However, I've got a problem here in that my background color for this view is by default white. So it's doing this all on a big white rectangle that includes those corners. So I need to stop my background from being white, and I also need to tell the system that my playing card is not opaque. Okay? So I'm going to do that in init with frame down here, but I'm going to do it in the right way, which is to have a setup method. And in setup, I'm going to set my background color to nil, which means I don't draw a background for me. And I'm going to set opaque to no, I'm not opaque. I'm also going to do that content mode equals UI view content mode redraw. Remember I told you that if my bounds ever change, I want to get my draw rect called. Now my bounds is not going to change in this demo, but I know that if it ever does, that's what I want. And then really importantly, I want to make sure I do this in awake from nib. Okay, self setup. Because in fact, in this demo, I am going to be creating this view in a storyboard. I'm not doing alloc init on it. So this is how I'm going to get set up. Okay, question?
What's the advantage of setting background color to nil instead of UI color, clear color?
Yeah, so the question is, what's the advantage here of saying nil versus UI color, clear color? The answer is there's no advantage, except for that really what I intend here is I don't have a background color. So you can argue it's just a style thing, but there's no difference in there. Okay? So now we're nice and set up. One thing I'm going to show you real quick here is pound sign pragma. I don't know if you guys know about that. How many people know what pound sign pragma is? Okay, almost nobody. This is awesome then. Okay, so if you do a pragma mark, you can put a comment like initialization like this, And now up here, see where it says implementation playing card view? If I click on that, you see how it's put a line here? That's this dash is this line, and then initialization appears here, and it's grouped these for me. So I can put like up here as well, # pragma, mark, drawing, and maybe up here I could put # pragma, mark, properties. And then my stuff really gets nicely grouped, okay? So something to think about there. All right, so back to here. So now I've got my background white in a rounded rect, which is great, but I actually also want to draw a little black line around the edge of my card, okay? So how would I do that? Very, very, very simple. I'm just going to set my stroke color, which is UI color, black color, set stroke. And then I'm going to ask this rounded rect thing, this Bezier path, to stroke. Okay? And it's going to have the default line width, which is probably 1 point, which is what I want, but I can make it thicker or whatever. So let's go ahead and run and see how things look so far. Now this is not going to work, and I'm doing this intentionally because you'll probably do the same thing. Let's put this down here. There we go. Surprised that doesn't do that. Okay. So you can see that I don't have my rounded corners and I don't have a black line. Why is this? Anybody know?
Because you didn't hook up the class on the...
Exactly, because I didn't hook up the class. Okay, so if I go back to my storyboard here, this is still a plain UI view. You see? UI view. So I need to change this to be a playing card view. Now when I run, the system knows that's a playing card view and I get a nice rounded Rex. Okay? See my corners cut off there? It's all good, and there is a little black line around there. It's hard to see, but it's there. Okay? All right, so we're off and running here. The next thing I'm going to do is draw the corners. You know, like where it says ace of clubs, and it's in the corner is an ace, and then underneath is a club, and then down in the other corner is upside down ace, and then clubs above it. You know what I'm talking about in a playing card? So we're going to draw that. I'm going to do that by saying, again, let's make more space here. I'm going to say self draw corners. Do this in a different method. I draw corners. Okay. So to do this, I'm going to use NS attributed string. Okay. And what I'm going to do is I'm going to make the string that I'm going to put in that upper corner be ace, carriage return, clubs. Okay. So I'm just going to put that in the upper left corner. Bingo. That's all I need. But there's two things I need to set in my attributed string. One is the font, and I'm going to use a preferred font. And number two is I need the paragraph style to be centered. I want those two things, the ace and the clubs, to be centered on top of each other. I don't want them to be left aligned. That's going to look weird, especially like a 10 of clubs would look really funny. I want them to center up. So we didn't really talk about how to set that kind of paragraph level alignment and stuff in a attributed string. So here's a chance to show you. So to do that, we use this class called paragraph style. Okay, paragraph style specifies things like the alignment of a paragraph. So I'm going to create a mutable one that I can set things in. And I do that with NS mutable paragraph style, alloc init. And then I'm going to set the paragraph style's alignment to be NS text alignment centered. So that just means centered. And then I'm going to set this as an attribute on my attributed string. The other attribute I need is the font. So I'm going to say a corner font here. And whoops, font. And I need, of course, to use a preferred font. And, you know, there's some arguments here. What would be the best UI? The best style here? You know, maybe headline, maybe even subheadline. But I'm going to try body. And we'll see how it looks, and if I don't like it, I could go change it to something else. But there's something really important to notice about this font. It's going to come in a certain size, whatever the size the user wants. Old people like me want big ones so I can see, and younger people like you probably want the smaller ones. But we still need to scale it from there. So we want to use that information, but then we want to scale it, again, depending on how big our card is. Big cards want big font, little cards want little fonts. Okay? So we're going to scale it just by creating a new font here. And we're going to do that. Make sure I do this the way that I predefined it here. So I'm going to do this by saying corner font font with size. So this is a method in font, an instance method in font that says create me a new font that's just like the font I'm sending this to, but with a different size. And the size I'm going to use is corner font's current size. Point size is the property in a font that tells you what its current point size is, times that corner scale factor that I used earlier up here to do this corner radius, okay? So this is this corner scale factor. I'm using the same factor here. And again, we'll see if that turns out to be right. If not, we can always change it. So now let's go ahead and create this attributed string. I'm going to call this the corner text. And it's just an NS attributed string. Alec init with string. The string I'm going to create is NS string with format. As I promised, %@, carriage return, %@. Okay. The first thing is the rank. So I need self rank as string because my rank is a number and I need it as a string. So I'm going to go up here and really, look at that, rank as string. So same thing we did before, a little array with that in there, self rank. I don't do any bounds checking and stuff. This demo is light on bounds checking. You know, good code would protect yourself a little better. And then here is the suit. Okay, suit. All right, so make sure I have my square brackets right here. Self suit, no. And there we go. So there's the string, and then with the attributes we're going to set here is a dictionary, and I need to set the font. Font attribute, what's it called again? Font attribute, NS font attribute name. And that's the corner font right there. And then I need NS paragraph style attribute, which is a new one you haven't seen before, and we'll call that paragraph style. Okay, close curly brace. Oops, thank you. Maintain that. Okay, are we good there? I think we got it. Okay, so there's the corner text, which is just this carriage return thing centered with the hopefully a good size font. And now I'm going to get the bounds of that. Okay, I'm going to get the bounds that I'm going to put that in. And there's two things to the bounds. One is the point, the upper left-hand point of it. And I could just make that be, actually I don't even need a local variable. Let's just go straight to bounds.origin. So I could make that be 0, 0, actually. But then my little A return clubs might kind of bang into my rounded rect a little. So I want to move it in a little bit. But again, it depends on how big the rounded rect is to how much I want to move it in. So let's say CG point make, how about self corner offset, self corner offset. And corner offset is another little method I put up here that's also related to this corner radius. You see, I took the corner radius, divided by 3. It looks like that's probably about right. Again, these are numbers you would want to play with when you're designing your UI. These numbers seem to work pretty good. And then the size of this rectangle, I actually need to ask the attributed string to tell me corner text size. You know, how big is that A return club's going to be? Because I don't know, right? The attributed string can tell me though. So now I have a rectangle that I'm going to draw the A return clubs in, and it's going to be centered horizontally on it. And all I need to do is tell it to draw, corner text, draw in rect, text bounds. Okay, so now it's drawing in that rect, so it's going to be doing the text alignment inside that rectangle. Okay, so that's it. So let's hope this works. And it doesn't work. Now why does this not work? Well, because we haven't set any card. This playing card view is not displaying any particular card. So we need to go back to our view controller and set that card to something. And a great place to do that, for testing right now anyway, is in view.did_load. So we're just going to pick a particular one. We also need to make an outlet to our card here so we can talk to it. So we're going to start here. I'm going to go over here. I'm going to control drag to create an outlet. I'm going to call it playing card view. Okay, so here's an outlet, so you can see what this is about. Okay, this is just an outlet, IB outlet. It's a playing card view, so we need to import playing card view. All right, so that works, that's good. We have our playing card view, so I'm just going to set my playing card, self.playing card view. I'm going to set its suit to be hearts, and then I'm going to set its rank to be king. Okay, that's my favorite card, King of Hearts. So let's set this to hearts. Oops, special characters. There's a heart. Oop, missed it. Characters, here's a heart. Did I get it that time? Yeah. Okay, so there's the King of Hearts. So we're going to do that. So now we run, and we should hopefully get the King of Hearts. There it is. And the sizes look pretty good there. Okay. Now, if I were debugging this, in fact, let's just do it. Let's make this card really small. See what happens. Let's try this. And that looked good too. Okay, so I'm pretty happy with that. And then I would also want to go to settings and set the fonts bigger and smaller and make sure that still works. But, you know, so far, I'm pretty darn happy with it. Now, of course, I checked this before I came today. I'm not going to totally do this on the fly. So there we go. Now, what do we need to do next? Well, now we need to put that King of Hearts in the other corner, upside down. Okay, now you might think, oh, great, upside down. Well, how are we going to do this? Turns out to be very, very easy to rotate what you draw in Core Graphics. So we're just going to do that. We're just going to do exactly what we just did, but rotate it upside down. So I'm going to go back here. I'm going to do the same thing, this draw and rect. Okay? But before I do it, inside here, I'm going to rotate it upside down. First, I'm going to move down to that corner. Then I'm going to rotate upside down. So how do we move over to a corner? Well, let's use one of these CG functions that I told you needed the context for. So let's get a context, ref, context equals UI graphics, get current context. I told you that's how you get the current context. Now that I have it, I can use CG translate, what's it called? Anybody remember? Translate something, context translate or something. There we go. Translate CTM. CTM is our transformation matrix. Okay, so we're just going to translate, which means move it. So I'm going to move it down to self.bounds.width and self.bounds.height. Okay, move down to the corner there. Oops, did I type something wrong? Size, oops, size. Size, okay, self.bounds.size.width, self.bounds.size.height. So I'm moving down to the bottom corner there. Remember, our origin is in the upper left. And now let's rotate. This is rotate CTM, context. And this is radians. So I'm going to go halfway around, in other words, upside down, which is m underbar pi. Pi radians is halfway around a circle. I want it to be upside down, directly upside down, 180 degrees from where it was before. And that's it. Okay? So I've translated and rotated what I'm going to draw, and then I'm just going to draw the exact same thing again. Bingo. Okay? So some stuff is really, really easy to do in Core Graphics. Okay, rotating, translating things, super, super easy. All right, so we're good there. Okay, the next thing we want to do is draw the face of the card. Okay, that King of Hearts face. Now, the face of the card is one of two ways. Either it's a face card, like the King, or it's just the pips, right? Little, like 4 of hearts is 4 little hearts in there. Okay, so we have to do both ways. So let's do the face card one first. Okay, so I'm going to do that up here, back in DrawRect. So I'm in DrawRect. And what I'm going to do, I'm just going to kind of have a design here where if I can find an image that has the name of the card, I'll use it. Otherwise, I'll try and draw pips. Otherwise, I'll draw nothing. Okay? So it's kind of a fairly safe way to go about it. If I can't find the face card image, then it'll just be, I'll still have the corners, but I won't have any drawing. So how am I going to do that? I'm just going to look up the image. I'm going to say UI image. Let's make more space again. UI image, face image. And I'm going to say UI image. I can use factor image, image named. And I'm going to make a string of format. And it's going to have the rank and the suit. Okay, self, rank as string, self, suit. Okay. So there's the image name. So I'm going to look that image up. So that would be like J spades, right? 10 hearts. It's not going to find 10 hearts. There's not going to be this other thing, but there will be K clubs, right? It'll find those. So if it finds the face image, then I'm going to display it in the middle. Otherwise, I need to draw the pips, basically, because it's not a face card. And so let's put a little draw pips here. Okay, we'll do that later. So the face image, how do I do this? Well, really I just need to tell UI image, draw this in the middle of my card, but I want to move it in from the edges a little bit, right? Because I don't want whatever the face image is, like a king, to smash my corners. Okay, my little king of hearts. So I want to move it in a little bit. So I'm going to create a rectangle to scale my image into, image rect. And it's going to basically be my bounds, except for I'm going to use this CG rect inset method here to inset it just a little bit. And I'm going to inset it by self.bounds.size.width times 1.0 minus a new property that I'm going to invent called face card scale factor. So the face card scale factor is going to be like 0.9 to be 90% of the size of my card. Okay, 0.9 would be 90% of the size of the card. And then same thing with size.height. Oops, heap sort, no. Height times same thing, 1.0 minus self.face card scale factor. All right, and we have to go make this property, so let's go do that. Let's go up here, put it in our property second. I'll type it really fast. Again, sorry to have to use those, but some things are boring to type. All right, so I have this face card scale factor. It's a float. I'm going to override both the setter and the getter. Okay, in the getter, I'm going to make sure that it's at least a default value. Okay, 90% is going to be my default value, so it's at least going to be that default value. And in my setter, I'm going to call set needs display, because if someone sets that scaling, I got to redraw my card if it's a face card. Okay, everyone understand this? And since I do both the setter and the getter, look what I have to do: synthesize. Okay, everyone remember that? If you implement both the setter and the getter, you got to synthesize yourself. Okay, good reminder of that. Okay, so now I have this image rect, and it's inset by that, whatever that percent is, 10%. If it's, 90 would be 1.0 minus 9. That's 10% of my width, 10% of my height. And so now I just say face image, draw in rect, image rect. Okay, and it will scale it to fit in that rect. Now I need these images, so let's go grab those. I happen to have them handy right here. Okay, so here's a bunch of images that I have for face cards. Let's just go ahead and drag them into our assets library here. Image assets. So here's our image asset library. We don't have any yet. Drag that in there. While I'm here, I'm also going to drag our famous Stanford one. And actually, let's get the high-res one too. Okay, we'll use that as our card back again. Okay, so we got all our images here. So the images look like this. Let's put the high-res one in for the King of Hearts at least. So here's the King of Hearts. I have high-res for all of them, but just for time constraints, let's go ahead and put this guy right here. Okay, so we get that one at least. All right, I'd want to drag them all in for all of them. But anyway, so now I have these images. So now when I run, it's going to go look for the images of these names, you see, and it's going to find the King of Hearts there. Okay, so that's Suicide King, right? Looks pretty decent. Size is pretty good. Okay. All right, so now we are going to do two quick things. I know we're right on the edge of time here. We're going to do the gesture recognizers really quick. So I'm going to do two things. One is let's make this playing card view work face down. And we're just going to do that by saying if we're face up, then we'll do this, all this stuff. Otherwise, we will just do our background image, UI image, image named, favorite card back. I'm going to change it to that. And then draw in rect, self.bounds. So if the back, I don't have the corners, and so I can just go ahead and use the whole thing. So card back. Okay, so now we have the front, the back there rather. So now since face up, it starts out not face up. So here it is. But I need to flip this over. So let's do a swipe gesture to flip that over. Okay, and the swipe gesture we're going to do using Xcode. Okay, so swipe gestures go like this. You go down here, you get in the object palette, same place buttons are, and you'll see that there's these gestures here. And I'm going to take a swipe gesture and drag it onto the view that I want to recognize that swipe, which is my playing card view, obviously. Then I simply control drag from this little icon that appears down here. You see it? Swipe gesture. You can also do it from here, this little document outline, which we don't have time to talk about today. Okay, but you can do that too. But I'm going to control drag from here. Oops, go auto, controller, and you just drag it out. It's very much like target action. Okay, I'll call this a swipe just to make it clear. And the argument is a swipe gesture recognizer. I'm not sure why it doesn't default to that. And we have the swipe. And the swipe, all we need to do is say self.playingCardView.faceUp equals not self.playingCardView.faceUp. Oops. Up. Just flip it over. Okay? Here it is. I'm going to swipe. Okay, the default swipe direction, by the way, is to the right. So I'm swiping, and you can see that it's flipping the card back and forth. By the way, you can inspect which direction the swipe is by clicking on it and going to the inspector. And there's right, left, up, down. So that answers your question. Those are the only 4 there are. And how many fingers have to be involved? 1 finger, multiple fingers, etc. Okay? And lastly, I'm going to do a pinch gesture. And I'm going to do the implementation of the pinch gesture entirely in the view. Okay, so I'm going to add a new method to the view, which is pinch. And it's going to be a UI pinch gesture recognizer. Okay, now this pinch is really simple. It's just going to say if the gesture's state is changed, oops, not began, changed, or if the gesture's state is ended, okay, then I'm simply going to take this face card scale factor that I have and multiply it by the gesture scale. But I don't want that to accumulate, so I'm going to set the gesture's scale back to 1.0 all the time. So that the next time I get called, I'll get the incremental scale. Okay? So that's all that's necessary there. I'm actually going to make this public because I want to be able to add this gesture recognizer in my controller. So let's just add this here, just so my controller knows that my card view is capable of this. Then I simply go in ViewDidLoad and say self.playingCardView, add gesture recognizer. And I'm just going to create a new UI pinch gesture recognizer, Alec. Init, you'll see that this is the designated initializer. The target is going to be the view, and the action is going to be pinch. Okay, so that's it. So this is how you add this in code. Everyone understand this? So I'm adding it to this view, creating it. This is the target. The view is going to handle it. It's going to handle the pinch. We handle the swipe, but the view is going to handle the pinch. All right, so let's see, what does that do? That should allow us, when we have a card here, if I pinch, to change the size, because it's adjusting that face card scale factor. You see? Make sense? But all we need to do to add the deck here is to go back to our controller and add, well, first of all, let me drag the model in. I got my model right here. There's my model, same model we used in Machismo. And I'm just going to go here and add that deck. Strong non-atomic deck star deck. Let's go ahead and import playing card deck. Let's also import playing card. All right, so now we have that deck. Here is the lazy instantiation of the deck. You know about that. I'm also going to have this method I'm going to call draw random playing card. Okay, this method, it's just going to draw a card from that deck. It's going to see if it's a playing card. If it is, it's going to cast it so that we have a local variable. Then it's going to set that in the playing card view's rank and suit to the card's rank and suit. Okay? And I'm going to do that every time we swipe and it's face down. Okay? So that's that. So here it is. So now when we swipe over, we get different cards. Okay, we have no pips yet. I'm going to do that in a second. But we do have the face cards, the Jack of Diamonds. Kind of low res because I didn't add the other ones in there, but King of Clubs. Okay, now let's do the pips real quick. The pips are super simple, especially if you have a little snippet here. So remember we had this draw pips. Okay, I'm just going to replace that with an implementation of that. You can go look at this offline, what pips does. It's pretty straightforward. It just uses attributed strings or maybe even just regular strings to draw. So let's see what that looks like. So there's our card. And there we go, 6 diamonds, 4 clubs, 7 spades. And the last thing I'm going to do, let's resize this view and make sure it still looks good small, even with all the changes we made. So we'll make it like this big and run. And still looks okay. A little squishy with the pips, but let's see a face card. That's not bad. Okay, that's it for today. Sorry to keep you so long, and I will see you all on Monday.
For more, please visit us at stanford.edu.